I asked to go on a little bit early because this is the end. Thanks for sticking it out, sticking around and capping this thing off with me. It's my first summit, so I've enjoyed it a lot. I hope you have too. Yeah, I'm trying to keep things a little informal. I know we got a lot of people have already left, so hope you have a lot of questions. I'm going to try to finish early and give a lot of time for that. But yeah, thanks for being here. I'm Sam. I'm a data scientist, Sam Staley, in the Department of State, the U.S. Department of State. I'm also a project manager. That's kind of out of necessity, just how we've grown so quickly, that I have a technical background, but also am a project manager. I think one of the themes I've seen throughout this summit so far is that people are there's a lot of stumbling into data science coming from different areas. Math in the medical professions. I work with an astronomer. I'm a geographer by trade. So I think it's terrific that everyone's getting a chance to be here and be technical and learn about how we're implementing things. This talk will be a little bit perhaps of a kind of a low level, maybe a beginning level for a lot of you, because it's not Gen AI. It is AI, it's machine learning, and there's a little bit of LLM kind of thrown in as a bonus, but this is primarily a use case in machine learning, process that we've implemented in the State Department and is now in production. It was one of our few and like actual production ML projects. So we're excited. That's why I'm here and spreading the word to you and the public and the rest of the government. We're trying to do a lot of exchanges on that. So that's why I'm here. I hope you ask a lot of good questions. And I know people are still going to be rolling in a little bit. And my timer hasn't started, so I'll keep doing a little dance. No, yeah. We are pretty limited. I'm in the State Department, in the federal government. We are on MAG, so all the cool things I've learned about, a lot of the cool things I've been learning about, I'm putting on a wish list and telling my colleagues, because it's going to make this job easier. It's going to make a lot of our jobs easier. But this project in particular, I'm going to be talking about one for a very small portion. But this project on declassification is based on our classified network. So we're even one step removed from a lot of the really cool technologies that we've been learning here. We're very open source by necessity in this project. But it's still very cool, and I'm going to try to mix in a lot of lessons learned and good practices for developing an ML model kind of from scratch. So I hope you have a lot of good questions about that. I'm going to keep doing a little bit of intro. I work in the Center for Analytics within the State Department. It's our enterprise data management, data analytics branch. We partner with other offices throughout the State Departments. We have our fingers in a lot of areas, at posts across the world, in administration bureaus, in diplomatic security, in all sorts of, it's kind of everywhere. So my office is led by the Chief Data and AI Officer. That's Dr. Matthew Gravis. He's the one in the mask right there. I'm several steps below him, but I do report everything to him. And right now, our entire focus here is AI. We are all in on AI and trying to be the leader, not just in the State Department, but in the federal government for implementing this responsible AI. So we just filled out our enterprise AI strategy that just went live a couple of months ago, and it's led by our Chief Data Scientist and Responsible AI Officer. And I could probably talk to you for another hour about how we are adhering to the executive orders that have recently come out, the OMB memo 2410 on security impacting AI projects and rights impacting AI projects, of which this project is one of two in the State Department. Actually, the two I'm talking about are the two in the State Department that are safety impacting and rights impacting projects, in which we have to do some extra documentation and reporting to the public and to the federal government. Now I'm going to give you a little background on the impetus for this project. It all comes from another executive order, 13526, which was signed in 2009. and it deals with how we handle classified information. I'm talking classified in this because it's going to get a little confusing. I'm talking about a classification model, but classified data in the sense of national security information. So this data lives on a separate network. It lives on our ClassNet network. And part of managing this data means that when its period of protection is up, when we're talking about confidential and secret specifically, we're not talking about top secret data in this project yet, because that's another network removed. Our secret network, when that period of protection is up, that information is automatically declassified. That's what this executive order says, unless you have given it an explicit reason to be exempt from declassification. So remember those words, declassified and exempt from declassification, because those are the two things that I'm looking for. I'm trying to automate that process. So it establishes a review process. That means every year we manually review everything that is up for declassification, which is a time-consuming process, as you see here. This is where we are coming. Let's talk about cables specifically, because this is one of the many data sets, one of the many data types that we're working with. It's not really data in the sense that it's how we communicate with the posts and with our department. It's an official form that is signed through the appropriate chain of command that says, I'm doing this, or I would like you to do this. So it's a very bureaucratic process, but it means that we have a data set that is structured in format and has structured metadata, and it's something that we use for a lot of our NLP testing and putting into practice, because it's a wealth of historical information about how the department operates. So right now, I'm going to use this. Right now, we are looking at take 2024 minus 25 years, 1999 cables. We right now have about 100,000 cables per year that we have to review. That can be done manually. It's always been done manually. It takes a year to do. But if that doesn't happen, there's a national security risk to that. If we're not able to review every document that is up for declassification, it gets automatically declassified and not quite released. There's a difference between releasing the document right away, because there's redactions involved, et cetera. But there's a national security risk to that if we are not able to review all of those documents. And then it goes to the National Archives. They do an additional review, and then it gets placed on an archive. We're kind of, I'll get to announce that we're not subverting that process, but we're taking a step in between the National Archives process. And we're not even looking at classified emails right now. It's such a negligible amount, it doesn't take a lot of time to do. But look how quickly we go up to millions of emails that we have to then work on declassification. So within the next 6-7 years, 7 times as many cables we have to handle, and we have to start reviewing emails very quickly. We can't do this right now with our current workload. So what have we tried to do to approach this? We started small. We limited our scope. We did a 3-month pilot over 3 years of cable data. That's just about 400,000 records. And we said, over 3 months, could machine learning learn the difference between a declassified and exempt cable? And can we use this in production? We had some good success with that, so we moved it along. And humans are always in the loop. That's a big part of the OMB memo 2410. We must keep trained professionals understanding the outcomes of the model and reviewing. So we're training only on human decisions, and we're retaining those same humans, to help us quality control check all of those decisions. I'll tell you how that worked in 2023 here in a second. So here's what we started in 2022, fall of 2022. We started our pilot. It took 3 months over cables that were declassified from between 1995 and 1997. Trained a model and had reasonable success. So our partners in the Bureau of Administration who own this process, they came to us and asked for help. Said, let's go, let's build it out. Let's try this in our live 2023 review of 1998 cables. So we started it. We refined the model. We gave some additional training in early 2023. We loaded our model predictions into the automated declassification review tool. That's the tool that helps reviewers say yes, no, type in reason. I'll talk about public release. shortly. We finished this review in 20 weeks. So 120,000 records should have taken all 52 weeks. We finished it in 20 weeks. So, spoiler, it works really well. And so at the end of the year, we started piloting a new data set, our Secretariat tracking and review system files, which are a slightly less structured data set. And so we've had some issues with that involving, and they're not digitally native. I should mention that cables are digitally native files. And so we had, again, that structure that was useful. Stars are not digitally native. So we've had OCR, we've had plenty of issues with the transferability of that model, which are new lessons learned we'll be able to report on next year. Right now, currently, as we speak, our models are running on the 2024 review. We've already given a small set of quality-controlled model decisions to reviewers. So we are actively in this 20-week cycle right now. Right, a little bit of the back end. As I said, we're largely open source, and that's by necessity because we live on the classified network, where we have VMs and we have a Conda environment, essentially. And so we're working with a lot of Python tools, open source tools. Elasticsearch is our backend for text storage and retrieval. And then we do have MLflow, open source MLflow for model tracking. We have about 35 models that we run every time and find the best model when we do this. So it's important to keep track of our hyperparameters. We do that with MLflow. That feeds back into the client database. That's our official record-keeping database that's managed by the Bureau of Administration, which is built on Elasticsearch. So we have a lot of interoperability with that. I'll go into a little bit more detail into this green box in a quick second. All right, so I said this is a binary, at its root, it's a binary classification tool. Now I'm talking machine learning classification tool. So the idea is, can we train a model to determine a declassifiable document from an exemptable document? It could be that easy. We just divide a threshold at 50% and say greater than 50, less than 50. Let's make those decisions. Manual review, no need to do it. Let's just send it out. We probably still get about 98% accuracy doing that because we have a very imbalanced data set. Only about 2 to 3% of cables every year are exempt from declassification. We're declassifying 100,000 records every year plus. So imbalanced data set means that we're also less accurate on the exempt side than we are on the declassify side. So we said, let's add a second threshold. Let's make a third bucket where we can do the highly confident declassifications, the highly confident exemptions, and everything in the middle. Maybe humans need to review those. Maybe the model needs to learn more to understand that. So we're sacrificing a little bit of the work saved. We're sacrificing the effort saved by automating a decision. But in the process, we're improving our F1 score. We're improving our risk tolerance with that. And so these are just examples. 0.1 and 0.9 are pretty extreme, but that's actually where we live. And I'll show you that's significant because that still represents a high percentage of our cables. But we can play with these thresholds every year. Every year it's a little bit different because of the nature of the cables. Every year it's a little bit different for the risk tolerance of our partners. As I said, they move around every 2 years. We might get somebody new that governs this process who thinks very differently about AI or about our ability to release more information. So we can play with these thresholds very easily. I think it's a little bit of an innovative approach to this, but our partners were very happy with it. So I said within this green box, these are the collection of tools that we're using to generate these 35 models. We're largely in Python and Elasticsearch. Python grabs from Elasticsearch, and then we feed that to a Kibana dashboard. Kibana is the front end from Elasticsearch dashboard, a very easy drag and drop dashboard tool. So we can expose that front end to our partners, and they can explore the topics, the trends in our cables, the spacey entities, et cetera. So I won't go through all of those, but in that second bucket there, we have some of the models that we're using, some of those 35 models. XGBoost routinely is our best performing model for this task. But sometimes random forests work. Sometimes GenSim is a better model. But XGBoost is almost always our highest performing. Point out Spacey. We're using a lot of entity, event, location polling from that, because who is in those cables has a lot to do with whether that remains classified or exempt. And SHAP, if you haven't used SHAP before, SHAP is very cool for feature importance, produces some really cool metrics on what features in the information are coming out and helping it make those decisions. So that's been very helpful for us. LLMs, I said that was going to be a bit of a bonus. We've started integrating some semantic embeddings into these models, and it's helping us with some of the more specific tasks. Some of those 35 models that we run every year are not just determining declassify exempt, they're determining whether we also need to refer this information to another agency. We can declassify 80% of the cables, but then another 10% of those might have equities related to Department of Energy because of nuclear issues, CIA, and so we have to build separate models to help us make those decisions. And LLMs are much more because they can get at that specific context, they've helped us a lot with making those decisions, though it's a little bit behind our accuracy right now. So that's our next step. Okay, so we took this model and we applied it. We did it in 2023, and we said reviewers hadn't seen anything. We ran these new 1998 cables through our model, and what this is showing right over here is the model made confident decisions on 61% of those 121,000 cables. So even if we just said, okay, great, let's just automate that, without a quality control, we could have saved 61% of the workload and asked reviewers to review the last 39% of those unsure bucket. And we said, that's a very high risk tolerance or low risk tolerance. So we chose a sample of the confident decisions and asked the reviewers to quality control those. Using a power analysis, we determined how many from each of those buckets, the unsure bucket, the declassified bucket, and the exempt bucket, they needed to review. And based on that power analysis, they actually exceeded our expectations for error rate. So that was a really good success story. But we took those samples, the 2.5% from each of those buckets, and we refed them into the model. So now because we have new data that we can train our model on, we added it to the existing trained model, reran it on those 39%, and now the model is confident in an additional 92% of those remaining cables. It's about a total of 80% of the yearly cables were seen and given a confident decision by the model. So that was a huge success to us and demonstrated the power of quality control and the power of retraining the model and not just trusting that first run. So we gave them another quality control check, gave them samples of the confident decisions. We of course gave them all of the remaining unsure bucket and said, model just doesn't know. You have to take care of that. They did. I do want to address the one thing at the end that says that our error rate was higher than we expected. This is actually another success story because that means that the model, or what ended up happening was the model was identifying some other aspect of the declassification guide that was in disagreement with the manual reviewers. We went over those specific cables they disagreed on, and we said, what's going on here? And they said, oh, you're right. We misunderstood this, and the model was more successful than the humans. I left that in because they went in, they re-reviewed with the new guidance and reached our expectations, but the model pointed something out that they wouldn't have done on their own. So when you say, I'll head off one of your questions. It's always asked, how do we feel about the model making decisions about what you, the public, get to see and what you don't see? Well, anything that is released to the public is seen by the model and a human. But humans are not infallible as well. To date, it's been a very subjective process. And sometimes it's seen by two reviewers, and sometimes they disagree. A lot of times they do agree, but we're providing some consistency to this process. This is just a visual, just a Sankey representation. If you're a visual thinker like me, and the percentage of documents that were seen by by the model and what were reviewed by the humans. There's that shrinking unsure bucket as we move along, and it shows me how few of these models were actually seen, or how many of the decisions were seen by reviewers, and to still generate that confident response. So 80% of those decisions had been seen by, or been accepted AI predictions, and 2% of the exemptions, 2% of all the cables were ultimately exempted. Reviewers looked at every one of those cables. Everything that we have said we have to keep back for national security reasons, a reviewer has looked at and reviewed. Okay, a little bit of the impact and what this means. Since we could up to 80%, remove up to 80% of the manual effort here, this is not taking into account that there was quality control and some duplicate quality control. So it wasn't exactly 80% of the time, but up to 80% of the time means we can focus on other initiatives beyond cables, the STARS files, the emails that are coming out, tons of paper files that haven't even been digitized. That's a whole different team that just scans through boxes and boxes of paper. And as I said, it lowers the risk of our unintended disclosure. So as we can set these thresholds, we can say, this year our intention is to err on the side of release. So let's minimize the exempt bucket, really make that threshold very high. So we're lowering that risk and quality controlling those. It's kind of adaptable to other data. We're trying really hard to apply it to the STARS files, and finding we just don't have a large enough training set. So we've been asking reviewers to look at files, and we're just not confident enough in that. But that is coming, and I think it's an adaptable approach, and it's what other agencies have told us. We've been meeting with them and talking about our process, and it relies on the data that it's given. So it can be adaptable to those processes with a sufficient training set. And it's very repeatable. So we're making more consistent decisions, and we're as I said, we're enhancing those policies and gaining a better understanding of our declassification guides and training the reviewers to do this. And transparency, and that was the title of the talk. So we're increasing transparency because we're making this process quicker, and means we can proactively disclose documents. So this is the second time we've been able to announce publicly that we're releasing documents that is going through this model. We are releasing them publicly on our FOIA reading room. So normally we go through our declassification process. We hand it off to NARA, and NARA does an analysis, and they put it on their website. And we said, we just declassified this. It was confirmed by a model and a reviewer. Let's just throw them on our public website. So FOIA.state.gov, check back in to that frequently, because we'll be releasing cables as they're going through this process. It was just a couple of weeks ago, I went to the Society for History in the Federal Government, because this is huge for historical research, to be able to release these old cables about what the department is doing. And we said, here you go, take the link. We're doing this. It's fresh off the classified network. So it's exciting and a positive thing. Okay, so I mentioned FOIA. Now I'm gonna talk about the other side of this project, and then I'll get into lessons learned at the very end. We are trying to automate the FOIA process, the Freedom of Information Act, which is how the public is able to request information about government processes and functions. We're trying to make that more streamlined. We have a huge backlog of requests. That's why if you've ever submitted something, it takes a long time to get a response back. The media does this a lot, but researchers as well, asking for information about how we are doing business, and we're obligated to provide that information. So we're tackling this we're trying to tackle this in about 3 different ways. So we're trying to improve the customer experience. Once you've submitted a FOIA request, it might be days until you hear something back, and we're trying to do that with automated generation of time and information immediately to you. I'll explain that in a second. We're trying to improve the search adequacy, because you get free text. Someone says, I want information on this, and if they don't have a date range, if they don't have names, if it's not, it's keywords that we are that there is a team trying to interpret and spread through the department that I think you have information related to this request. So we're trying to improve that adequacy and then minimize the redundancy of those searches, which kind of overarches both. This is kind of the way what we're thinking here in a very overview sense. And this is very internal. As this is the public's going to see some of this because we're proactively trying to respond. But when a request comes in, we can submit it via a Power App. And it goes through our repositories of previously released information, and with the intention being, somebody last week just submitted the same request, and we responded to it up here. Go to the go to this website and view the information. Or it's a partial response. Well, here are some documents on our public reading room that you can go see while you're waiting for a more thorough response. And this is where you're doing this with a lot of different tools. And since this is now on the open network Databricks, and is a huge part of this, interacting with our official record store, as I said, and FOIA Express, the public interfacing part of this, as well as Kibana. So we're trying to reduce this duplication. If something has already been released, here you go. It's already out there, and really trying to speed this process up. It's time intensive, it's manually intensive, and it's not fair to the public who don't get a response when you need it. It's a work in progress. This project has been going on for about 12 months, and we're still working through a lot of it. But we just this week shadowed a bunch of the FOIA teams that do some of this searching and processing of requests, and they're excited to start using this tool to try to reduce their workload. Okay, some of the unique challenges we faced, I'll go kind of quickly through this, but as I said, since we're training this model, these models on information that has been declassified in the past, there's a very real chance that over time we're going to experience some data drift, some model drift. And so it's important to do this retraining process. Once we get human reviewed decisions, we need to feed them back into the model so that we're keeping it up to date with geopolitical contexts, with entities, and all of that. So we're frequently retraining the model to try to accomplish this, and incorporating the human quality control over every step. As I said, imbalanced data is a big problem here. So we're doing a lot of undersampling of our majority declassified data set, and doing a lot of outlier analysis to accommodate for that. Referrals are a huge aspect of that. As I said, it's a subset of those declassified documents. And again, now we're using an AI model that's somewhat of a black box, and we need to be able to explain that to the public. As I said, SHAP is a big part of that. Unfortunately, because we're identifying features that can identify exempt documents, our SHAP model lives on the classified network. So that is more for our internal. But we're trying really hard to take into account. So as I say here, so we're not using subsections of models of cables. Declassification is an all or nothing approach. So there might be very specific pieces of information in those cables that mean that the whole thing must be exempt. So we're not dealing with redactions or any of that right now, but we will hopefully be getting to that point very soon. All right, and finally, the lessons learned. So we found, obviously, data management is such a huge part of this. We've had a great relationship with not only the bureau that owns the declassification process and our official record keeping, but the diplomatic technology office that actually owns the system. They have implemented so many usability requests from us for new metadata. If you don't have access to the data store to be able to suggest new metadata as it's ingested, that has been huge for us. So working with partners that can manage the data, that can help, and not only are we can feed back, as I said, our our success and our suggestions back to the data management groups. So they've implemented a lot of those changes for us. Start small. So in the government, I feel we don't get a lot of opportunity to try with the intention of, or with the idea that maybe it won't succeed. We were given a lot of leeway from our Bureau of Administration partners to say, try it for 3 months. It's a low obligation. If it doesn't work, we haven't spent a lot of time, but if it does work, we stand to gain a lot of information. So we are trying to take this pilot approach to a lot of the work we do, not diving in too deeply, and as we go, requesting new packages, as we go, iterating on that. And choosing a document type. Again, it goes back to data management, but why it is important that we used a very structured data set that is not going to scale to the rest of the department, but is important to help us prove the viability of the process. And process transformation, and by that I mean working with the people who are right now doing this job. We couldn't have done it if we hadn't have engaged those manual reviewers, our retired Foreign Service officers that in all likelihood wrote these cables, but know more than anyone about the function of the department back when these things existed. So we immediately engaged them and we said, how would you interact with this? If you had model decisions and someone was already making decisions for you, how would you do it? So we changed the interface, we gave them confidence measures, and we said, we're not taking your jobs. We're making it easier for you to do all of the other crap that you have to do for declassification, and they were on board from the very beginning and have helped us. So that's what I mean by integrate it with the process, integrate it with the current policies. That's it. I left a lot of time for questions, so I do want to hear from you.